In the coming videos, we'll be discussing focal chord, normal chord, and various other chords of a parabola. So in this video, we'll discuss certain things about chords of a parabola. So we'll take a standard parabola, which is y square is equal to 4x. Now suppose we have any chord, say PQ. Now this is P and this point is suppose Q. Now any point on parabola, we can write it in terms of parametric coordinates. So suppose it is AT1 square twice AT1, and suppose point of this Q is AT2 square twice AT2. Now there are several things that you will work out for this chord PQ. First is slope of this chord. So what is slope of this chord PQ? So slope is y2 minus y1. So we can write 2a and then t2 minus t1 and then x2 minus x1. So if I take a common, I can write t2 square minus t1 square. So this a will cancel and then a plus b and a minus b. So a minus b will also cancel. So slope of this chord, it will be 2 upon t1 plus t2. Now second thing that you will work out for this chord is equation of this chord. Now since we have this slope and we can use any one point, we can write this equation as y minus y1. So it is y minus twice a t1 and then m, which is 2 upon t1 plus t2, and then x minus x1, which is a t1 square. So we'll multiply this t1 plus t2. We can write t1 plus t2y and then minus 2a t1 square minus 2a t1 t2, and here we'll get 2x and then minus 2a t1 square. So minus 2a t1 square will cancel. So we can write this equation as t1 plus t2y minus 2x, and it is twice a t1 into t2. So that is the equation of any general chord of a parabola. Now third thing that we'll want to work out for any chord is length of the chord. So in this we'll find length of this chord PQ. So length of this chord PQ will be under root of x2 minus x1 whole square. So there will be a and then t2 square minus t1 square whole square and then plus twice a, and then it should be t2 minus t1 whole square. Now here we can take this a out and we can also take t2 minus t1 out. So we can write this length as a and then mod of t2 minus t1, and then what we're left with is under root of t1 plus t2 whole square and then plus 4. So length of any general chord of a parabola will be a mod of t2 minus t1 under root of t1 plus t2 whole square plus 4. We'll be using this formula of length for focal chord and normal chords, and then there'll be some locus problems on length of chord of any general parabola. Now there can be questions on chord of a parabola which subtends a right angle at vertex. Now what is the condition for that? So now again, suppose here parameter is t1, here parameter is t2. We'll find slope of OP. What is the slope of OP? Slope of OP is y minus y1 upon x minus x1. So it will be twice a t1 upon a t1 square. So I'll get 2 upon t1. What is the slope of OQ? So it will be 2 upon t2. Now since OP and OQ, they are perpendicular to each other, we know that product of slope should be minus 1. So we get 2 upon t1 into 2 upon t2. It should be minus 1. So from here we'll get the condition as t1 into t2 should be minus 4. In this video we'll discuss a line and a parabola and its condition of tangency. Now this method, it is a very general method and it can be used for any general second degree conic. So suppose we have this parabola which is y square equals 4ax, and then we have this line y equals mx plus c. Now with parabola and line, we have three separate possibilities. Either this parabola and line, they will never intersect, or this parabola and line, they will intersect at two distinct points, or this parabola and this given line, they are tangent to each other. So they'll touch each other. Now, how do we find this condition? So what we'll generally do in this question is, in this question, we'll find points of intersection. And how do we find point of intersection? So for point of intersection, we'll just need to eliminate the variable. So I'll put the value of this y in this equation. So for point of intersection, I can write mx plus c whole square, and this is 4ax. So I can open this square. So I can write m square x square plus c square plus twice mc into x, and this is 4x. Now I can write it as a quadratic equation in x. So I'll write it as m square x square plus 2m into c minus 2a into x, and then plus c square equals to 0. Now this is nothing but a quadratic equation in x. Now we know that for a quadratic equation, there are three possibilities of its roots. So either this quadratic equation has two real roots, or it will have equal roots, or it will have no real root. So when we take d greater than 0, then we get two separate values of x. So that means this parabola and line, they'll intersect at two distinct points. So in this case, we'll have a condition where this parabola and line, they intersect to form a chord. Now when d is equal to 0, so that simply means there is only one point of intersection. So if there is only one point of intersection, then it clearly means this parabola and this line, they'll touch each other. And if d is less than 0, it simply means this parabola and line, they do not have any point of intersection. In that case, this line and parabola, they'll never intersect each other. So this is how we can work out the three conditions, whether a given line is going to intersect a parabola at 2 points, or it will touch this given parabola, or they'll never intersect each other. Now we need to also work out condition of tangency. So we know that for condition of tangency, this value of d, it should be 0. So if we take d equals 0, we can write d equals to 0 as b square, which is 4 m into c minus 2a whole square, and then minus 4. What's a? A is m square, and then c square, and it should be 0. So I'll cancel this 4 with 4. So I can write m square c square plus 4a square minus 4a m into c minus m square c square, it should be 0. So m square c square will cancel. So I can write 4a into mc should be equals to 4a square. So I'll cancel this 4a also. So I'll get c equals a by m. So that is the condition of tangency of this line and parabola. So this line y equals mx plus c, it will touch this parabola when the value of c is equal to a by m. Now once we have this value of c, then we can write equation of tangent for this parabola also. So we know that for this parabola, y square equals 4ax. This line y equals mx plus c is a tangent when the value of c is a by m. So what we can simply say is, if we have this parabola which is y square equals 4ax, and for this parabola, if we need to write equation of any general tangent, then equation of tangent will be y equals mx plus c. And what is the value of c? C for this parabola should be a by m. So this is how we can write equation of any general tangent to this given parabola, which is y square equals 4ax. Now here the question is, if this line x plus y equals k touches the parabola y equals x minus x square, we need to find value of k. So again we find point of intersection. So I'll replace this y with k minus x. So I'll write k minus x, and this is x minus x square. So I can write this quadratic equation as x square minus 2x and then plus k equals to 0. Now condition of tangency is value of d, it should be 0. So then I'll get 4 minus 4k equals to 0. So that means value of k simply should be 1. So this line will touch this parabola when the value of k is simply 1. Now in the previous video we have discussed how to find condition of tangency for a line in a parabola. We can use the same method for condition of tangency for a circle and a parabola. In this question it says a circle which is x square plus y square plus 2 lambda x equals 0 and y square equals 4x, they touch each other externally, then we need to find value of lambda. So again, what we'll do is we'll substitute the variable. So I'll write y square as 4x. So I can write this equation as x square plus 4x plus 2 lambda x equals to 0. So it'll be x square and then plus, I'll take 2x common and then it'll be 2 plus lambda equals to 0. Now this quadratic equation, it should have only one root. Otherwise, it will intersect at two distinct points and it will have only one solution when the value of d is 0. So value of d is 0 when b square minus 4ac is 0. So here I'll get 2 into 2 plus lambda whole square, it should be 0. So that is value of lambda should be minus 2. So this circle and this parabola, they'll touch each other when the value of lambda is minus 2. Now again in this video, we'll be discussing a very interesting equation of parabola which touches both the axes at a distance of a and b units from the origin. So what I'll do is I'll draw this parabola. So suppose this is origin and then we have this parabola which touches both the axes. At a distance a and at a distance b units from the origin. We need to find equation of this parabola. Now we know that any general equation of parabola, we can write it as ax plus by whole square plus 2gx plus 2fy and plus c equals to 0. Now this parabola, it touches x-axis. Now we need to find condition of tangency of this parabola with x-axis, and x-axis is simply y equals 0. So if we put y as 0, then we can get this equation as a square x square plus 2gx and plus c equals to 0. Now for this quadratic equation, there should be only one root, that is the value of d, it should be simply 0. Now we also know that it's a quadratic equation with a double root at a comma 0. So that means this quadratic equation should be in this form, a square into x minus a whole square, and it should be 0. So if I'll square it, I'll get a square x square minus twice a into a square x and then plus a square into a square, it should be 0. So if I'll compare, then I can write g as minus a into a square and c as a square into a square. So that is the condition we'll get from this condition of tangency with x-axis. Now in the same way, we use condition of tangency with y-axis. So with y-axis, we'll put x as 0. So if I put x as 0, then we can write it as b square y square plus 2fy plus c equals to 0. Now this quadratic equation, it has a double root at 0 comma b. So then it should be b square into y minus b whole square, it should be 0. So I can simplify it as b square y square minus 2b b square y and plus b square into b square should be 0. So we'll compare the two equations, then we can write 2f, it should be equals to minus, or I should say, if we compare the two equations, then we can get f equals minus b into b square and then c is b square into b square. Now we'll compare these two values of c, then we can write a square into a square is equal to b square into b square, or we can write b into b is equal to plus minus a into a. So we can write b as plus minus a upon b into a. So if we take this plus sign, then this equation will represent a pair of straight lines. So we won't consider that case. We just need to find equation of parabola. So I'll take this minus sign. So I'll write b as minus a upon b into a. Now in the same way, I can write this g as minus a into a square. Now what's f? F is minus b and we can write b square as a square upon b square. So a square upon b square. So I'll write f as minus a square upon b, and then we can simply write c as a square into a square. Now we'll substitute these values in this first equation. So we can write it as ax, and then in place of b we can write minus a upon b, a into y whole square, and then plus 2gx. Now 2gx will be minus twice a into a square x, and then 2fy will be minus 2 a square upon b into y, and then plus c, and c in this case is plus a square into a square, it is equal to 0. Now what I can do is I can take this a square common and I can cancel it from this equation. So I can write this equation as x minus a upon by whole square minus 2ax minus 2a square y upon b and plus a square, it should be equals to 0. Now if we'll divide this equation with a square, small a square, then we can write this equation as x upon a minus y upon b whole square, and then minus twice x upon a minus 2 y upon b and plus 1 equals to 0. So I can write this equation as x upon a minus y upon b whole square, and then minus 2, I'll take common, and then x upon a plus y upon b, and then plus 1 equals 0. Now we'll try and make it a perfect square of x upon a plus y upon b. So what we'll do is I'll add 4 xy upon ab and I'll subtract 4 xy upon ab. So I can write this equation as x upon a plus y upon b whole square minus 2 x upon a plus y upon b and then plus 1, and I'll take this minus 4xy upon ab on the right hand side. I'll write 4xy upon ab. Now this is a minus b whole square, so I can write it as x by a plus y by b minus 1 whole square, and it should be 4xy upon ab, or we can write x upon a plus y upon b minus 1, and this is plus minus twice under root xy upon ab. So we can write this equation as x upon a plus y upon b plus minus twice under root xy upon ab, and this is equals to 1. Now this is a square plus b square and then 2ab. So we can write it as under root of x upon a plus minus under root of y upon b whole square. This is equals to 1. So we can write this equation as under root of x upon a plus under root of y upon b equals to 1. So all throughout this proof, we have been discarding this minus sign because in that case, I will represent the part of the same parabola or it will represent a straight line. So equation of this parabola which touches the axis at a distance of a and b from origin is given by under root of x upon a plus under root of y upon b equals to 1. So if we have this parabola which touches both the axes, then we can simply write this equation as under root of x upon a plus under root of y upon b equals to 1, where this point of contact is a comma 0 and this point of contact is 0 comma b. So this is how we can write equation of this parabola touching both the axes. So now we look at equation of tangent to a parabola. So if I have this parabola which is y square is equal to 4ax and we need to find equation of any tangent to this parabola. So we know that line y equals mx plus c will be a tangent to this parabola when the value of c is a by m. So for this parabola, if we need to write equation of tangent, we'll just write this equation of tangent as y equals mx plus a by m, where m is the slope of this tangent. So if we have slope and if we have this equation, then we can simply write equation of tangent to this parabola as y equals mx plus a by m. Now another way of writing this equation of tangent is in terms of its parametric coordinate. So suppose if I'll say point of contact of this tangent is suppose p, and this is at square and twice at. Now we can use calculus to find slope of this tangent. We know that for this parabola y square equals 4ax. So we'll differentiate, we'll get 2y dy by dx is equal to 4a. So we'll find dy by dx at this point p. So dy by dx at this point p will be 2a upon y. And what is the value of y? Y in this case is twice at. So it will simply be 1 upon t. So that means slope of tangent at any point at square twice at will simply be 1 upon. So if we replace m with 1 upon t, we can write equation of tangent as y equals, and in place of m, I'll write 1 upon t. So it will be 1 upon tx and then plus at. So we can simply write it as ty equals x plus at square. So for this parabola, y square equals to 4ax, we can write equation of tangent as either in terms of slope, which is y equals mx plus a by m, or in terms of its parameter t, which is ty equals x plus at square. And we know that relationship between m and t is slope of this tangent should be 1 upon t. So for a parabola, if I know this parameter t, we can write this point of contact also, and then we can write equation of tangent also, which is ty equals x plus at square. So when we'll be proving questions on parabola, we'll be mostly taking this equation, which is ty equals x plus at square. But when we are given slope of a tangent, then in that case, we'll use this equation, which is y equals mx plus a by m, where m is slope of this tangent. If I'm given slope of this tangent, I can not only write this equation of tangent, I can also write this point of contact. So this point of contact of this tangent, P, we can write it in terms of m also. We know that m is 1 upon t and this point is at square twice at. So its point of contact should be a upon m square and 2a upon m. So if we are given slope of a parabola, then we can write equation of tangent and point of contact. And if we are given parameter t also, then we can write point of contact and equation of tangent. So for this first form, y square is equal to 4ax, we have equation of tangent in both in terms of m and in terms of t. In the previous video, we have discussed that for this parabola y square equals to 4ax, equation of tangent we can write it as either y equals mx plus a by m, or we can write it as ty equals x plus at square. Now we'll discuss equation of tangent for other three forms. So if we have the second form, which is y square equals minus 4ax. Now for this parabola, all I need to do is I'll just need to replace a with minus a. So if I have to write equation of tangent for this parabola, I can simply write this equation as y equals mx minus a by m, or if I have to write in terms of parameter t, I can write ty equals x minus at square. Now what about this third form? So for this third form, which is x square equals 4ay, we need to write equation of tangent in terms of its slope. Now we know that difference between first and third equation is if I interchange x and y, I'll get the first equation. So for this third equation, if I have to write equation of tangent, we can write this equation as x equals, suppose m dash y plus a upon m dash. I can rewrite this equation as m dash y, and this is x minus a upon m dash, or I'll write y is 1 upon m dash x minus a upon m dash square. Now what is the slope of this tangent? So slope of this tangent is 1 upon m dash. So what I'll do is I'll let 1 upon m dash as m. So if I replace 1 upon m dash as m, I can write this equation of tangent as y equals mx minus am square. So for this third form, equation of tangent will be y equals mx minus am square. And for this fourth form, which is x square equals minus 4ay. Now for this parabola, again we'll replace a with minus a. We can write this equation as y is equal to mx plus a m square. So this is how we can write equation of tangent for any of these given four forms. Now for this third form, we'll also write it in terms of parameter t. So for this third form, we know that any point on this parabola, it will be 280 comma 80 square. Now if we'll differentiate this curve, we can write 4a dy by dx, and this should be equals to what? 2x. So dy by dx equals x upon 2a, and what's x in this case? X in this case is simply 280. So 280 upon 2a. So for this third form, slope of tangent will be equal to this value t. So we will replace t with n. We can write this equation as y equals tx minus at square. So for this third form, equation of tangent in terms of parameter t will be y equals tx minus at square. Now for this third form, m is equal to t, and for this first form, we know slope of tangent is actually 1 upon t. And for this fourth form, we can write this equation as y equals tx plus at square. Now what if we do not have a standard parabola, but a parabola whose vertex is shifted? Say for example, suppose we need to write equation of tangent for this parabola, which is y minus k whole square equals 4a and then x minus h. So what we'll do is, we'll compare it with the standard parabola, which is capital Y square equals 4a capital X. Now for this parabola, we know that equation of tangent will be y equals mx plus a by m. So all I simply need to do is, I'll just need to replace y with y minus k and x with x minus h. So I can write this equation as y minus k equals m x minus h plus a by m, and that is the equation of tangent to this parabola whose vertex is at h comma k. So this is how we can write equation of tangent to any parabola whose axis is parallel to either x-axis or y-axis. In this video, we'll learn another way to write equation of a tangent, and this is the simplest way to find equation of a tangent if the point lies on the curve. And this method, it is applicable in the case of circle, parabola, ellipse and hyperbola also. So first we'll need to learn some general notation for that. So suppose I have any curve whose equation is represented by s equals 0. Now say for example, let us consider parabola of the first form. So which is y square minus 4ax equals 0. So in this case, y square minus 4ax, that's your s. So when I write s equals to 0, that will be the equation of given curve. It could be circle, parabola, ellipse or hyperbola. So what I'll do is, I'll also take up an example. Say for example, suppose I'm given a parabola which is y square plus 8x minus 3 equals to 0. Now, suppose I'm given any point which is x1 comma y1. Now say for example, for this parabola, suppose I'm given a point P which is 0 comma root 3. Now we have equation of the curve and we are given some point. So first notation that we'll learn here is something called as S1. Now S1 is nothing but S1 is the value of S if I put this point in the equation. So in this case, S1 simply will be y1 square minus 4a x1. So if for this curve, suppose this is S, which is y square plus 8x minus 3, then if I'll put the value of x and y, x as 0 and y as root 3, then I'll get 3 plus 0 minus 3. So this is 0. So if I'll put the value of this point x1 and y1 in the equation, I'll get some value. So this value, it could be positive. This value, it could be 0, or this value, it could be negative. Depending on the value of S1, we can find position of a point with respect to a given curve. So suppose we have any parabola. If S1 is less than 0, so that means that point, it will lie inside the parabola. If S1 is positive, if S1 is greater than 0, then this point, it will lie outside the parabola. And if S1 equals to 0, then the point satisfies the equation of the curve. So in that case, that point, it will lie on the parabola. So if S1 is positive, it simply means this point lies outside the parabola. If it is 0, it will lie on the curve. And if it is negative, then it will lie inside the curve. So there could be questions on position of a point with respect to any curve. It could be circle, ellipse, parabola, or hyperbola. Now in this case, this S1, it's 0. So that means this point, it satisfies this equation. So this S1, this point, it lies on the given parabola. Now if point lies on the curve, then in that case, equation of tangent is given by t equals 0. Now we need to know how to write t equals to 0. So from this given S and this given point, we need to write equation of some line which is t equals to 0. Now how do we write t equals 0? So for t equals 0, what we'll do is we'll replace x square with x into x1, y square with y into y1, x with x plus x1 upon 2, and y with y plus y1 upon 2. And if we'll substitute these in the given equation, then we'll get equation of a line, and that equation, we'll say that equation is t equals 0. So say for example, for this parabola, if I have to write t equals to 0, then in place of y square, I'll simply write y into y1 and then minus 4a. Now in place of x, we'll write x plus x1 upon 2. So it will be x plus x1 upon 2 equals to 0. So t equals to 0 represents this line, y1 minus 2ax minus 2a x1 equals to 0. So from the given curve or from the given equation s equals to 0 and a given point x1 y1, we can always write this equation which is t equals 0. So when the point lies on the curve, in that case, equation of tangent is given by t equals to 0. So in this case, this point, it lies on the curve. So if we have to write equation of tangent, then we know that equation of tangent simply will be t equals to 0. And that's the simplest way of writing equation of tangent when the point lies on the curve. So in place of y square, we'll write y into y1, and y1 in this case is root 3. So it'll be root 3y and then plus 8. And in place of x, we'll write x plus x1 upon 2. Now x1 here is 0. So it'll be x plus 0 upon 2 minus 3 equals to 0. So we'll get this equation as root 3y plus 4x minus 3 equals to 0. So equation of tangent to this parabola, which passes through the point 0 comma root 3, is given by root 3y plus 4x minus 3 equals 0. So this method, it is applicable for any curve. So even if it is circle, ellipse, hyperbola, or a parabola, if the point lies on the curve, if we have to find equation of tangent through that point, then all we simply need to do is to find t equals to 0 by replacing x square with x x1, y square with y y1, x with x plus x1 upon 2, and y with y plus y1 upon 2. And then we'll get this equation which is t equals to 0, which when a point lies on the curve is going to represent equation of tangent. Now let us take another example. Say for example, we are given this parabola which is x square plus 6y minus 7 equals to 0, and we are given this point which is 1 comma 1. Now first we'll find S1. So all I need to do is, I'll just need to put the value of x and y. So it'll be 1 plus 6 minus 7. So which is 0. So that means this point, it lies on this parabola. Now if I have to write equation of tangent is given by t equals to 0. So in place of x, I'll write x into x1. Then in place of y, I'll write y plus y1 upon 2. And then minus 7 equals to 0. So it'll be x plus 3y plus 3 minus 7 equals to 0. So this is x plus 3y minus 4 equals to 0. So equation of tangent which passes through 1, 1 is x plus 3y minus 4 equals 0. So if a point lies on parabola, then t equals to 0, it will represent equation of tangent. So it is when the value of S1 is 0. Now what if S1 is greater than 0? So if S1 is greater than 0, it simply means this point, it lies outside this parabola. Now, if a point lies outside parabola, it simply means two tangents can be drawn from this given point. So in that case, we'll have a pair of tangents. Now, equation of tangent in this case is not t equals to 0 because now this point P, it doesn't lie on parabola. So if we look at this point of contact, so suppose this is A and this is B. So this chord of parabola AB, this is called as chord of contact. So if the point P lies outside the parabola, in that case, equation of chord of contact is given by t equals to 0. So t equals to 0, it is equation of tangent only when this point P, it lies on the curve. If the point lies outside or inside, in that case, it doesn't represent a tangent. Now, when the point lies outside, it represents this chord of contact. Now, when the point lies outside, then equation of pair of tangents is given by SS1 equals t square. So if we have to find combined equation of pair of tangents, then that equation can be represented as SS1 equals t square. So say for example, suppose we have this parabola which is y square minus 8x equals to 0, and suppose we have this point which is 1, 3. So we'll find S1. So this is 9 minus 8, which is 1, which is greater than 0. So that means this point P, it lies outside this parabola. So if we have to write equation of chord of contact, then chord of contact in this case will be t equals to 0. Now how do we write t equals to 0? So there will be 3y minus 8 x plus 1 by 2 equals 0. So equation of chord of contact will be 3y minus 4x minus 4 equals to 0. So that is the equation of chord of contact and not the equation of tangent. Now we know that equation of pair of tangents is given by SS1 equals t square. What is S? S is the equation of given curve. So which in this case is y square minus 8x into S1. What's S1? S1 in this case is simply 1 and equals to t square. And what's t here? T is 3y minus 4x minus 4 whole square equals to 0. And that is the equation of pair of tangents drawn from this point 1, 3 to this parabola, which is y square minus 8x equals 0. So this is the general notation and the simplest way to write equation of a tangent when a point lies on the curve. Now let us take some questions. We'll start with questions on general chord of a parabola. So we are given a parabola which is y square plus 4y and this is equal to 4 by 3x minus 16 by 3. So what I'll do is I'll complete the perfect square. So I'll add 4 both sides. So I can write this equation as y plus 2 whole square, and this is 4 by 3x, and then minus, so it'll be 12, 4. So again here will be 4 by 3. So I'll take 4 by 3 common. So I can write this equation as y plus 2 square 4 by 3, and this is x minus 1. And I'll compare it with the standard equation, which is capital Y square equals 4a capital X. So in this case, capital Y is y plus 2, capital X is x minus 1, and the value of a is 1 by 3. Now it says chords of parabola which subtends right angle at the vertex pass through a fixed point, and we need to find that fixed point. Now for this parabola, first we'll write equation of any general chord. So in previous video, we have already done this equation of a general chord. So equation of a general chord for this parabola, y square equals 4ax. It is given by t1 plus t2y equals 2x plus 2a t1 t2. So that is the equation of any general chord of a parabola. So we have this parabola which is y square equals to 4ax, and then we have this chord drawn at point P whose parametric coordinate is t1, and Q whose parametric coordinate is suppose t2, and this is t1 plus t2y equals 2x plus 2a t1 t2. Now we know that if this chord, it subtends right angle at vertex, then first we'll find slope of OP. So what is slope of OP? So this point P actually is a t1 square twice a t1, and this point Q is a t2 square twice a t2. So this is 2 upon t1, and slope of OQ is 2 upon t2. Now since OP and OQ, they are perpendicular, product of slope, it is minus 1. So from here we can say the value of t1 into t2 is simply minus 4. So we'll put the value of t1 t2 here. So we can write t1 plus t2y equals 2x minus 8a. Now this chord, it always passes through a fixed point. And what's that fixed point? So that fixed point is capital Y equals 0 and capital X equals 4a. Now what is capital Y? Capital Y is y plus 2. So we'll write y plus 2 equals to 0. So that means value of y is simply minus 2. And what is capital X? Capital X is x minus 1 and then 4a. What's 4a? So 4a in this case is 4 by 3. So 4 by 3 plus 1 is 7 by 3. So this point will be 7 by 3 comma minus 2. So chords of a parabola which subtend right angle at the vertex pass through 7 by 3 comma minus 2. Now here the question is, we need to find the values of m so that this line y equals to mx, it bisects two distinct chords drawn from 4 comma 4 on y square equals 4x. Now this point, it lies on this parabola y square equals 4x. So we'll draw this parabola. And then we have this point 4 comma 4, and it says two chords can be drawn from this point, and this line y equals to mx, it bisects the two distinct chords. So we have this line which is y equals mx, which bisects these two chords. So what I'll do is, I'll say, suppose this other end is at square twice at, and a in this case is simply 1. So it'll be t square comma 2t. Now we'll find midpoint of this chord. So what is the midpoint of this chord? So midpoint of this chord, it will be t square plus 4 by 2 comma 2t plus 4 by 2. So it will be t square plus 4 by 2 and then t plus 2. Now this midpoint, it lies on this line, which is y equals mx. So we'll put the value of x and y. So we'll get y plus 2 equals m, and then x in this case is t square plus 4 upon 2. So we can write it as mt square minus 2t plus 4m minus 4 equals to 0. Now in the question it says two distinct chords. So that means there should be two distinct values of t so that we can have two distinct chords for this given parabola. So how do we get two distinct values of t? So for two distinct values of t, clearly this quadratic equation should have two distinct roots. So that means in this case d should be greater than 0. So we'll find d greater than 0. So which is 4 minus 4m, and this is 4m minus 4, and it should be greater than 0. So I'll get 1 minus 4m square plus 4m greater than 0. So we can write this equation as 4m square minus 4m minus 1, and it should be less than 0. So I'll add 1 and subtract 1. So we can write this equation as 2m minus 1 whole square minus 2, and this should be less than 0. Now if we'll put m as 0, we'll get this value as minus 1. So this is correct. If we'll put m as 1 by 2, we'll get this as minus 2. Again, it satisfies the given condition. And if we'll put m as 1, again we'll get minus 1. But if we'll put m as minus 1 by 2, so in this case, it'll be 4 minus 2 plus 2. So then in that case, it won't be less than 0. So options B, C and D, they are correct in this case. Now here the question is length of chord of parabola y square equals 4ax, whose equation is y minus root 2x plus 4 root 2a equals 0. So we have this parabola, and then we have chord of this parabola, which is y minus root 2x plus 4 root 2a equals 0, and we need to find length of this chord. Suppose this is a and this is b. So we know that any point on this parabola, we can write it as at square twice at. So we'll find those points on this line which are of the form at square 2at. So we'll just put this value in the equation. So we'll get 2at minus root 2 at square and plus 4 root 2 a equals 0. So we'll cancel this a and we'll also cancel this root 2. So we can write this equation as root 2t minus t square plus 4 equals to 0, or t square minus root 2t minus 4 equals to 0. So we can write it as t square minus 2 root 2t and plus root 2t minus 4 equals to 0. So we'll get this as t plus root 2 and then t minus 2 root 2 comma 0. So value of t is either minus root 2 or value of t is 2 root 2. So now we have t1 and t2. So we know that length of chord is a mod of t2 minus t1 under root of t1 plus t2 whole square and then plus 4. So this length will be a. What's t2 minus t1? So it will be 3 root 2 and then under root of t1 plus t2 whole square. So t1 plus t2 whole square is root 2 square. So there will be 2 and then plus 4. So this length will be a into 3 root 2, and then this is root 6. So this length will be 6a into root 3, and that's your option number 4. Now here the question is, we need to find length of the chord of parabola x square equals 4ay, which passes through the vertex and have slope 10 alpha. So we have this curve, which is x square equals 4ay, and then we have this chord which passes through the vertex and having slope 10 alpha. So we have this chord which passes through vertex and whose slope is 10 alpha. Now we know that any point in this third form we can write it as 2at comma at square. So we'll find slope of this line, which is OP. So slope of this line OP simply will be at square upon 2at, and it is equal to 10 alpha. So from here we'll say, in this case, value of t is 210 alpha. Now we need to find length of this chord. So we already know that length of the chord is given by a t2 minus t1 under root of t1 plus t2 whole square plus 4. And in this case, suppose this is t2 and t1 simply is 0. So this length will be a, and then it will be 210 alpha, and under root of t1 plus t2 whole square. So there will be 410 square alpha plus 4. So now it will be 4a 10 alpha secant alpha. So length of this chord will be simply 4a 10 alpha into secant alpha. Now here the question is, we need to find the condition that this line 2bx plus 3cy plus 4d equals to 0, it passes through points of intersection of parabola y square equals 4ax and x square equals 4ay. So now we look at these two parabolas. They are symmetric about y is equal to x line. So we'll interchange x and y, we'll get these two equations. So both the point of intersection for these parabolas, they will lie on y equals to x line. So what we'll simply need to do is, we'll just replace y with x, then we'll get x as 0 and x as 4a. So these two points of intersections, they'll be 0, 0 and then 4a, 4a. So what is the equation of this chord? So equation of this line simply will be y equals x. Now we are given this line, which is 2bx plus 3cy plus 4d equals to 0. So the line which we have got is x minus y equals to 0. So these two lines, they are coincident. So from here we'll write 2b upon 1, 3c upon minus 1 and 4d upon 0. So from here we'll say 2b plus 3c should be 0 and d should be 0. So the option which was given in the question was this. So it was 2b plus 3c whole square plus d square equals to 0. So in case of real numbers, so x square plus y square, it can only be 0 when x is 0 and y is 0. So that's how we get this condition, which is 2b plus 3c equals 0 and d equals 0. Now here the question is, the length of chord of circle and y square equals 4x minus h is maximum, then we need to find the value of minus h. So we are given this fixed circle, which is x square plus y square equals 4. Now it says length of chord of circle and this parabola whose axis is x-axis. So we can draw this parabola in various forms. So we can draw this parabola like this. We may draw it like that. Now, what's the maximum length of any chord in any given circle? So maximum length of any chord in any given circle is diameter of that circle. So this parabola and this circle, they'll cut the chord of maximum length when the length of this chord is equal to diameter of this circle. So that means in that case, this parabola, it should pass through these 2 points. So what is this point? So this point is 0, 2 and this point is 0, -2. So this parabola, it should pass through 0, 2. So we just put the value of x and y. So we'll get 4 and this is 4 and minus h. So what is the value of minus h? So value of minus h in this case is simply 1. So length of this chord of circle and this parabola is maximum when the value of minus h is simply 1. Now here the question is, prove that on the axis of any parabola y square equals 4ax, there is a certain point k which has the property that if a chord pq of parabola be drawn through it, then 1 upon pk square plus 1 upon qk square is same for all positions of chord. Find also the coordinates of the point k. So first we'll draw this parabola. Now we'll draw a chord on this parabola, and suppose this fixed point is k, and suppose it is h, 0, and then we have this p and q. Now let us say this angle is theta and distance of any point on this line from k is suppose r. So we can write this equation of line as x minus h upon cos theta y minus 0 upon sine theta equals to r. So we can write the coordinate of any point p or q on this line as h plus r cos theta and r sine theta. Now these points p and q, they lie on parabola, so we'll just put the value of x and y in the equation. So then we can write it as r square sine square theta 4a h plus r cos theta. So we'll get a quadratic equation in r. So I'll write it as r square sine square theta minus 4a cos theta into r minus 4ah equals 0. Now this equation has two roots, say r1 and r2, and it says 1 upon r1 square plus 1 upon r2 square. This is constant. So I can write it as r1 square plus r2 square upon r1 r2 whole square, or we can write it as r1 plus r2 whole square minus 2 r1 r2 upon r1 r2 whole square, and this should be independent of theta. So we'll find sum of roots. So what is the sum of roots? So sum of roots r1 plus r2 in this case is 4a cos theta upon sine square theta, and what is product of roots? r1 into r2. r1 into r2 is minus 4ah upon sine square theta. So we'll just put it. So then we can write it as 1 upon pk square plus 1 upon qk square, and it should be equals to 16a square cos square theta upon sine to the power 4 theta minus minus will be plus 8ah sine square theta upon r1 r2 whole square. So it should be 16 a square h square upon sine to the power 4 theta. So we can write it as (16) a square cos square theta plus 8ah sin square theta upon 16 a square h square. Now what we'll do is we'll write cos square theta as 1 minus sin square theta. So we can write it as 16a square and then minus 16 a square sin square theta and plus 8ah sin square theta upon 16 a square h square. So now we'll take this sin square theta together. So we can write it as 16a square and then minus 8 sin square theta and I'll also take this a out. So then I'll get 2a and here we'll get minus h upon 16 a square h square. Now this result, it should be independent of theta. So it will be independent of theta when 2a minus h is 0. So from here we'll say the value of h should be 2a. So this fixed point k, it should be at 2a comma 0. Now we'll discuss some questions on tangent to a parabola. Now the question is the angle between the tangents drawn from the point 1, 4 to parabola y square equals 4x is. So we'll need to find angle between the tangents. So we know that for this first form, equation of tangent is given by y equals mx plus a by m. Now a in this case is 1. So we can write it as y equals mx plus 1 by m. Now these tangents, they pass through this point which is 1, 4. So I'll put y as 4 and x as 1. So this is m plus 1 upon m. So we can write this equation as m square minus 4m and then plus 1 equals 0. Now it's a quadratic equation in m. So what is sum of roots? So sum of roots in this case is 4. And what is product of roots? m1, m2 is simply 1. Now we need to find angle between these two tangents. So angle between line is given by m2 minus m1 upon 1 plus m1, m2. So first we'll find m2 minus m1. So m2 minus m1 is under root of m1 plus m2 whole square and then minus 4 m1, m2. So it'll be 16 minus 4, which is 12, which is 2 root 3. So tan theta will be 2 root 3 upon 2. So which is simply root 3. So in this case, value of theta simply will be pi by 3. And that's your option number C. Now the question is, tangent to the curve y equals x square plus 6 at a point 1, 7, it touches the circle at a point Q, then we need to find coordinates of point Q. Now this point 1, 7, so we'll put it in the equation. So if we'll put y as 7 and x as 1, so this point, it satisfies this given equation. So that means this point, it lies on the curve. And when the point lies on the curve, then the best way to find equation of tangent is simply t equals 0. So if we'll put t equals 0, in place of y, we'll write y plus 7 by 2, then x square is x into x1, and then plus 6. So this is y plus 7, and this is 2x plus 12. So we can write this equation as 2x minus y plus 5 equals 0. So that is the equation of tangent to this parabola at the point 1, 7. Now this tangent, it also touches this circle, which is x square plus y square plus 16x plus 12y and plus c equals to 0 at a point Q. Then we need to find coordinate of this point Q. So we have this line whose equation is 2x minus y plus 5 equals to 0, and this line, it touches this given circle whose center is at minus 8 comma minus 6. So now if you had to find point of contact, all I need to do is I'll just need to find foot of perpendicular from this center to this given line. So how do we find foot of perpendicular? So we have a direct formula for that. So it is x plus 8 upon 2 and then y plus 6 upon minus 1 and then minus, we'll put the value of this point. So it is minus 16 plus 6 plus 5 upon a square plus b square. So it should be 5. So we'll get this value as x plus 8 upon 2, y plus 6 upon minus 1, and this is 11, 5. So this is 1. So x plus 8 equals 2 and y plus 6 equals minus 1. So value of x is minus 6 and value of y is minus 7. So the coordinate of this point Q are minus 6 comma minus 7. Now here the question is, let a line y equals mx intersect the parabola y square equals x at a point P other than origin. Let the tangent to it at P meets the x-axis at a point Q, and if area of triangle OPQ is 4, then we need to find the value of m. So we have this parabola. Which is y square equals x, and then we have this line which is y equals mx, which intersects this parabola at point P. Now we have a tangent at this point P. Which meets x-axis at a point Q. So it says if area of this triangle OPQ is 4 units, then we need to find the value of this m. Now for this parabola, what is the value of a? So 4a is 1. So a simply is 1 by 4. So any general point on this parabola, we can write it as at square comma 2at. So we can write it as t square by 4 and then t by 2. Now for this first form, what is the equation of tangent to a parabola? So equation of tangent in parametric form is given by ty equals x plus at square. Now in this case, what is the value of a? A is simply 1 by 4. So we can simply write 4ty equals 4x and then plus t square. Now we need to find this point Q which lies on x-axis. So we'll put y as 0. We'll get x as minus t square by 4. So coordinate of this point Q will be minus t square by 4 comma 0. Now it says area of this triangle is simply 4. So we can write this area as this determinant 1 by 2 and then 0, 0, 1 minus t square by 4, 0 and then 1, t square by 4, t by 2 and 1, and this area it should be plus or minus 4. So we'll expand about this first row. We'll get 1 by 2 and then minus t cube upon 8, and this is plus or minus 4. We can write t cube as plus or minus 64, which is 4 cube. So that means value of t is either plus 4 or minus 4. Now we need to find slope of this line. So what is slope of this line? So slope of this line OP will be t by 2 comma t square by 4. So we can write it as simply 2 upon t. What is the value of t? T is plus or minus 4. So value of m should be plus or minus 1 by 2. Now here the question is, the tangents to the curve y equals x minus 2 square minus 1 at its point of intersection with the line x minus y equals to 3 intersect at the point. So we need to find that point. So we can write this equation as x minus 2 equals y plus 1. So we can write this equation as y plus 1 and we can replace x minus 2 with y plus 1. So it will be y plus 1 whole square. So we'll get either y plus 1 as 0 or y plus 1 as 1. So value of y is either minus 1 or value of y is simply 0. So we'll put value of y as minus 1. We'll get value of x as 2. And if we'll put y as 0, I'll get x as 3. So this parabola so it intersects this line x minus y equals to 3 at 2 comma minus 1 and 3 comma 0. Now we need to draw tangents to this curve at these points and we need to find their point of intersection. So we'll need to find this point of intersection. Now one way of doing it is using calculus. So we can differentiate this curve. We can write dy by dx as 2 into x minus 2. Now what is the slope at point A? So at point A, slope will be simply 0. And what is the slope at B? So we'll put x as 3. We'll get slope at B as 2. So what is the equation at A? So equation of tangent at A, it is y minus y1 equals m, x minus x1. So simply it will be y equals minus 1. And at B, equation will be y minus 0 equals 2, x minus 3. So it is y equals 2x minus 6. Now we'll put y as minus 1. We'll get 2x is 5, then x is 5 by 2. So their point of intersection will be 5 by 2 comma minus 1, and that's your option number C. Now the question is, if two tangents drawn from a point P to parabola y square equals 4x be such that slope of one tangent is double the other, then P lies on the curve. So it's a locus problem. So we know that equation of any tangent to this parabola is y equals mx plus a. A in this case is 1 by m, and we need to find two tangents drawn from point P. So let us say this point P is alpha comma beta. So we'll put the value of this point. So we can write this equation as beta equals m alpha plus 1 upon m. So this equation will be m square alpha minus m beta and plus 1 equals to 0. Now this is a quadratic equation in M. Now it says this equation has slope of one tangent double the other. So it means this equation has two roots which are of the form say t comma 2t. Now what is sum of roots? So this is 3t and will be simply beta upon alpha. And what is product of roots? 2t square, and this is 1 upon alpha. So we'll eliminate t. So we'll get 2 and t square will be beta square upon 9 alpha square, and this is 1 upon alpha. So this equation will be 2 beta square equals 9 alpha, so which is 2y square equals 9x. So locus of this point P will be 2y square equals 9x, and that's your option number B. The angle between a pair of tangents drawn from a point P to parabola y square equals 4ax is 45 degrees. Show that the locus of point P is a hyperbola. So again, we'll consider equation of tangent, so which is y equals mx plus a by m. Now we need to find locus of this point P. So we'll take this point P as alpha comma beta. So again, it'll become a quadratic in M. So it'll be alpha m square minus beta m and then plus a equals 0. Now again, it has two roots, m1 and m2. So sum of roots, beta upon alpha product of roots a upon alpha. Now it says angle between the pair of tangents is 45. So we know that tan 45 is equal to m2 minus m1 upon 1 plus m1 m2. So we'll need to find m2 minus m1. So mod of m2 minus m1 will be under root of m1 plus m2 whole square minus 4 m1 m2, and that should be under root of beta square upon alpha square minus 4a upon alpha. So it will be under root of beta square minus 4a alpha upon alpha. So we'll just put these values. Now tan 45, it is 1. m2 minus m1 is under root of beta square minus 4a alpha upon alpha, and then 1 plus what's m1 m2? m1 m2 is a upon alpha. So we can write it as a plus alpha is equal to under root of beta square minus 4a alpha. So now we'll square it. So if I'll square it, I'll get a square plus alpha square plus 2a alpha, and this is beta square minus 4a alpha. So we can rewrite this equation as beta square minus alpha square minus 6a alpha and plus a square equals to 0, which is a second degree equation in x and y. So we can rewrite this equation as minus x square plus y square minus 6ax and then plus a square equals to 0. So what's a? A is minus 1, b is 1, and h is minus 3a. H square is greater than ab, so which is a hyperbola. So locus of this point P will be a hyperbola. Now the question is, tangent is drawn to parabola y square minus 2y minus 4x plus 5 equals to 0 at a point P, which cuts the directrix at a point Q. A point R is such that it divides QP externally in the ratio 1/2:1. Then find the locus of point R. So first we'll rewrite this equation. So I'll add 1 and subtract 1. So we can write this equation as y minus 1 whole square, and this is 4 x minus 1. So we'll compare it with the standard equation. We'll get y square equals 4 times capital X. Now we need to consider a point P. So for this, let us say this point P is at square. A in this case is 1. So it will be t square comma 2t. And now we need to write equation of tangent for this point P. So for this point P, equation of tangent will be ty equals x plus at square. A in this case is 1. So it will be x plus t square. Now we need to find this point Q, which lies on directrix. So we know that at directrix, x is equal to minus a. So we'll put x as minus a. We'll get y as t square minus a upon t. So this point Q is minus a t square minus a upon t. So we'll need to find locus of this point R, which divides QP externally in the ratio 1:2:1. So that means we have this point Q, which is minus a, and I'll write this as t minus a upon t, and then P is t square comma 2t, and then we need to find this point R, which divides it in the ratio 1:2 ratio externally, and say this point is alpha comma beta. So we can write alpha as t square minus 2. What's the value of a? A is 1. So it'll be simply t square plus 2 upon minus 1. And what's beta? Beta is 2t minus 2 t minus 1 upon t upon minus 1. So here we can write t square equals minus alpha plus 2, and here 2 and 2t and 2t, it will cancel. So I'll get beta equals minus 2 upon t. So we'll eliminate t. So we'll eliminate t, we'll get 4 upon beta square equals minus alpha plus 2. So we can write this equation as alpha plus 2 into beta square equals minus 4. Now we'll change alpha with x and beta with y. So we can write this as capital X plus 2 capital y square, and this is minus 4. Now we know that capital X is x minus 1 and capital Y is y minus 1. So we can write x plus 1 y minus 1 whole square and then plus 4 equals to 0. So locus of this point R is x minus 1 y minus 1 square plus 4 equals 0. Now here the question is, consider a circle x square plus y square equals 9 and parabola y square equals 8x. They intersect at P and Q in first and fourth quadrants respectively. The tangent to the circle at P and Q intersect the x-axis at R, and tangents to parabola at P and Q intersect the x-axis at S. Then we need to find answers to these three questions. So we have this circle. Center at origin and radius 3. And then we have this parabola y square equals 8x. So they intersect each other at points P and Q. So first we'll solve their point of intersection. So we'll eliminate y square. So we'll put it in this equation. We'll write x square plus 8x minus 9 equals to 0. So it will be x plus 9, x minus 1 is equal to 0. So value of x is either minus 9 or value of x is 1. So x cannot be negative. So that means value of x is 1. Now if we'll put x as 1, we'll get y as plus minus 2 root 2. So that means this point P is 1 comma 2 root 2, and this point Q is 1 comma minus 2 root 2. Now it says tangents to the circle at P and Q intersect the x-axis at R. So we are drawing tangents to the circle. And they intersect each other at this point R. So we need to find this point R. So we know that this point, it lies on circle. So when the point lies on the curve, we know that equation of tangent is given by t equals to 0. So for this circle, t equals to 0 will be, so in place of x, we'll write x into x1. In place of y, y into y1, and this is equals to 9. So now we'll need this point which lies on x-axis. So I'll put y as 0. So I'll get x as 9. So this point R is 9 comma 0. Now it also says tangents are drawn to this parabola also. Now they intersect at the point S. Again, these points P and Q, they lie on this parabola. So again, equation of tangent is given by t equals to 0. So for y square, we'll write 2 root 2y, and then this is 8 and x plus 1 by 2. So now again, we need this point on x-axis. I'll put y as 0. So I'll get x as minus 1. So this point S is minus 1 comma 0. Now we'll find area of triangle SPR. So what's the area of this triangle? So it'll be half, and then what's the value of base? Base is 10. And what's height here? Height is 2 root 2. So it is 10 root 2. We'll also find area of PQS. So for this PQS, it is half, height is 2 units, and this is 4 root 2. So it is 4 root 2 square units, and we'll also find area of triangle PQR. So area of triangle PQR will be half, and then 9 minus 1, 8, and then 4 root 2. So it will be 16 root 2. Now what is the first question? First question is ratio of the areas of triangles PQS and PQR. So ratio of PQS upon PQR. So this ratio, it is 1 by 4, and that's your option number C. Now second question is, we need to find radius of circumcircle of triangle PRS. So for this triangle, we need to find radius of circumcircle. So we know that radius of circumcircle is ABC upon 4 delta. So what's A? Suppose this length is A, this is suppose A, that's B, and that's C. So A is 10, and what's the value of B? B is 8 square plus 8. So there'll be 64 plus 8, 72. 72 is 6 root 2. And then what is the value of C? So this is 2. 2 square is 4. 4 plus 8, 12. 12 is 2 root 3. Upon 4. And what is the value of delta? Now area of triangle SPR, it is 10 root 2. So root 2 will cancel. 10 will cancel. And then it will be 3 root 3. So that's your option number B. Now for this triangle PQR, we need to find radius of incircle. So we know that radius of incircle is simply delta upon S. So what is the area of triangle PQR? So area of triangle PQR is 16 root 2. And what is the value of S? S is semi-perimeter. So it is B plus B. So that is 2B. And then plus this value, which is 4 root 2 divided by 2. And what is the value of B? B is root 72, which is 6 root 2. So it will be 16 root 2, 12 root 2 plus 4 root 2. That will be 16 root 2. So 8 root 2. So this value is simply 2. So radius of incircle is 2 units. Now here the question is, a line y equals mx plus 3 meets y-axis at 0, 3, which is E. The arc of parabola y square equals 16x when y lies between 0 to 6 at the point F, x0, y0, and the tangent to parabola at F intersects the y-axis at G, 0, y1. The slope m of the line is chosen such that the area of triangle EFG has a local maximum. Then we need to find the correct match. So first we'll draw this figure. So we have this parabola, which is y square equals 16x, and then we have this line y equals mx plus 3, which intersects y-axis at this point E, which is 0, 3, and this parabola at point F, which is x0, y0, and we know that for this parabola value of a is 4. So we'll take this f in terms of parametric coordinates. So that is 8t square, 4t square, and then 2at. So it is 4t square, 8t. Now it says tangent at f intersects y-axis at G. So tangent at f intersects y-axis at this point G, which is 0, y1. So we can write equation of tangent in terms of parameter coordinates. So equation of tangent will be ty equals x plus at square, so which is 4t square. Now this point G, it lies on y-axis, so we'll put x as 0, we'll get y as 4t. So value of G is 0 comma 4t. Now we'll write area of this triangle EGF. So area of this triangle EGF will be half, and then this distance, which is 3 minus 4t, and then this height, which is actually equal to its x coordinate, that is 4t square. So we'll get this area as 2 and then 3t square minus 4t cube. Now we need to maximize this area, so we'll differentiate. So if I'll differentiate, we'll get d delta upon dt, so it'll be 2 and then 6t minus 12t square is equal to 0. So we'll get the value of t as either 0 or 1 by 2. So this is minus, plus and minus. So we have a local maximum when the value of t is 1 by 2. So in this case, value of t should be 1 by 2. So what is the value of G? So G will be 0 comma 2. So that means y1, it should be 2. Now what should be f? F is 4t square, so which is 1, and then 8t, which is 4. So x naught, it is 1, and y naught is 4. And if we have to find slope of this line, so what is the slope of this line? Slope of this line is, so we know that this point is 1 comma 4. So y2 minus y1 upon x2 minus x1. So value of m is 1. So this small m, it is mapped to 1, which is option number 4. Maximum area, so we'll just need to put the value. So we'll put the value of t as 1 by 2. We'll get this value as 3 by 4 minus 1 by 2. So it'll be simply 1 by 2. So maximum area will be 1 by 2. Y naught, so maximum area, it is 1 by 2. What's y naught? Y naught is 4. And what's y1? Y1 is 2. So it should be 4, 1, 2, 3. 4, 1, 2, 3. And that's your option number A. Now here the question is, a line bisecting the ordinate Pn of a point at square 280 when t is greater than 0. So first we'll draw this parabola. And then on this parabola, we have a point P, which is at square 280, and then we have this ordinate Pn. So this is n, and n is at square comma 0. Now a line bisecting the ordinate Pn. So a line bisecting the ordinate Pn. So equation of this line will be y equals at. Now this line, it intersects the parabola at Q. So for this Q, we know y coordinate is at. So if y is at, we'll put the value of y, and then we'll find the value of x. So it'll be a square t square, and then 4ax. So x in this case will be at square by 4. So coordinate of this point Q will be at square by 4 comma at, and coordinate of n is at square comma 0. Now it says nq, so this is nq. Meets the tangent at vertex at point T. We'll need to find this point T. So first we'll find slope of this line. So what is the slope? Slope is AT upon AT square by 4 minus AT square. So it will be AT and then minus 3 AT square by 4. So A and A will cancel. T will also cancel. So it will be minus 4 upon 3T. So now we'll write equation of Qn. So equation of Qn will be y minus 0 minus 4 upon 3T and then x minus AT square. Now for this point T, it lies on y-axis. So we'll simply put x as 0. If I'll put x as 0, I'll get minus 4 upon 3T and then minus AT square. So T and T will cancel. So we'll get 4AT upon 3. So answer to this question will be 0, 4AT upon 3, which is option number A. Now the question is, two straight lines are perpendicular to each other. One of them touches the parabola y square equals 4ax plus a, and the other touches y square equals 4bx plus b. Now first we'll take this parabola, so which is y square equals 4a x plus a. So we'll compare it with the standard equation, capital Y square equals 4ax. Now for this parabola, we can write equation of tangent as t capital Y x plus at square. Now in place of y, we'll write y, and in place of x, we'll write x plus a. So it'll be ty x plus a plus a t square. So that's my first equation. Now for this second parabola, which is y square equals 4b x plus b, this equation will be t dash y equals x plus b t dash square. Now we'll need to find locus of point of intersection of two lines. Now we know that these two lines, they are perpendicular to each other. What is the slope of this line? 1 upon t, and it is 1 upon t dash. So from here we'll get the condition as t into t dash should be minus 1. Now we need to find locus of point of intersection of these two lines. So first what I'll do is I'll replace t dash with minus 1 upon t. So I'll get minus y upon t x plus b upon t square. So we can write this as minus ty, and this is x plus b into t square and then plus b. So we can write this equation as x plus bt square plus ty plus b equals to 0, and this first equation as at square minus ty plus x plus a equals 0. Now we need to find locus of point of intersection of two lines. So this x and y, suppose it is the point of intersection. So I need the answer in terms of x and y. So I'll just need to eliminate this t. So what we'll do is we'll add the two equations. So if we'll add the two equations, we'll get x plus b plus a into t square plus x plus b plus a equals 0. So I'll take x plus b plus a common, and then it is t square plus 1 equals to 0. So condition should be x plus b plus a equals to 0. So locus of this point of intersection of two lines should be x plus b plus a should be 0, and that's your option number 3. Now the question is, if the tangent at P on y square equals to 4ax meets the tangent at vertex in Q and S is the focus of parabola, then we need to find this angle SQP. So we'll take this parabola. So we have this any point P, which is AT square 280 Now we'll draw tangent at this point. So this tangent, it meets the tangent at vertex in Q. So this point is Q and S is the focus. So S is A comma 0. We need to find this angle, angle SQP. So we know that equation of tangent at any point P will be Ty equals x plus a t square. Now for this point Q, it lies on y-axis. So I'll put x as 0. So if I'll put x as 0, I'll get y as at. So this point Q is 0 comma at. Now we'll need to find angle between S, Q and P. So we'll find M1 and M2. So what's M1? So M1 in this case will be at upon minus a. So it will be simply minus t, and we'll find M2. So what's M2? M2 is y2 minus y1. So there will be at and then upon at square. So it is 1 upon t. So from here we'll get M1 into M2 equals minus 1. So that means these two lines SQ and PQ, they are perpendicular. So angle between them is pi by 2. Now the question is, the straight line joining any point P on parabola to the vertex and perpendicular from focus to the tangent at P intersect at R. We need to find equation of the locus of R. So first we'll draw this parabola. So this is y square equals 4ax, and then we have any point P on this parabola. So this is point P, which is suppose at square twice at. Now straight line joining any point P to the vertex. So we need to join this P to O. So this is OP and perpendicular from focus to the tangent at P. So we have this tangent at P. And then we have this focus, which is A comma 0. So a line from focus and perpendicular to this tangent. It intersects at this point R. We need to find locus of this point R. So what we'll do is, let's say this R is alpha comma beta. So we need to find relationship between alpha and beta, and we need to eliminate this parameter t. Now for this OP and R, they lie on a straight line. So that means beta upon alpha, that is slope of OR, must be same as slope of OP, which is 2at upon at square. So here a and a will cancel, t will also cancel. So we'll get t equals 2 alpha upon beta. So that's my first relationship. Now the second is, we'll find equation of this line. So we have a point on this line. We have slope of tangent. We know that slope of tangent is 1 upon t. So here slope of this line will be minus t. So we'll write equation of this line will be y minus beta minus t and then x minus alpha, and this line, it passes through the point a comma 0. So I'll put y as 0. So I'll get minus b minus t and then a minus alpha. So from here we'll write t equals beta upon a minus alpha, and that's my second equation. So now we'll eliminate this parameter t. So we'll get 2 alpha upon beta equals beta upon a minus alpha. So I'll get 2a alpha minus 2 alpha square, and this is equals to beta square. So this equation is 2 alpha square plus beta square minus 2a alpha equals 0. So which is 2x square plus y square minus 2ax equals 0. So this is the required locus, which is option number B. Now the question is, if L and M are variable real numbers such that 5L square plus 6M square minus 4LM plus 3L equals 0, then variable line Lx plus My equals to 1 always touches a fixed parabola whose axis is parallel to x-axis. So first we'll consider a line. First we'll consider a parabola whose axis is parallel to x-axis. So we can write this equation as y minus k whole square equals 4a x minus h. So let this be the equation of this fixed parabola. Now it says this line Lx plus My equals to 1. It touches this parabola. So we'll solve this question using quadratic condition. So what I'll do is I'll eliminate x. So I'll write y minus k square 4a, and then in place of x we'll write 1 minus my upon L minus h. So now we can square it. We'll write y square plus k square minus 2ky into L, and this is 4a 1 minus my minus LH. So we can write this equation as Ly square minus 2kl plus 4am into y, and then plus k square L minus 4a, and then 1 minus LH equals to 0. Now we know that this line, it will touch this parabola only when we have one point of intersection, and the condition for one point of intersection is value of d, it should be 0. So for this quadratic in y, we'll put d equals to 0. So we'll take 2 common, so there'll be 4, and then 2am minus kl whole square, and then minus 4l, and here we'll get k square l minus 4a plus 4a LH equals 0. So this 4 and 4 will cancel. So we can write it as 4a square m square plus k square l square minus 4am lk minus k square l square plus 4al minus 4a L square h equals 0. Now here k square L square will cancel, and we can also cancel 4a. So we can write this as am square minus k into lm plus l, and minus h L square equals to 0. So we can write this equation as HL square minus am square plus k lm, and then minus L equals to 0. Now the condition given to us is 5L square plus 6m square. So it is 5L square plus 6m square minus 4lm and plus 3L, it is 0. So these two equations, they are coincident. So that means we can write this as h upon 5, and this is minus a upon 6, k upon minus 4, and this is minus 1 by 3. So if we'll take the first and last, we'll get h as minus 5 by 3, and taking these two, we'll get k as 4 by 3, and from second and last, we'll get the value of a as 2. So we can write this equation as y minus 4 by 3 square equals 8 x plus 5 by 3, which is capital Y square equals 4a capital X. Now for this parabola, we know that vertex is at origin. So capital X is 0 and capital Y is 0. So we'll put capital X as 0. We'll get X as minus 5 by 3 and we'll get Y as 4 by 3. So that's your option number A. Now second, we'll need to find focus of this parabola. We know that for the first form, focus is a comma 0. So capital X is A and capital Y is 0. So X here is X plus 5 by 3. And what is the value of A? A here is 2. And then Y minus 4 by 3 equals 0. So if we'll take it on the right hand side, we'll get X as 1 by 6 and Y as 2 minus 5 by 3. So that is 6 minus 5 by 3. So it is 1 by 3 and we'll get Y as 4 by 3. So its focus is at 1 by 3 comma 4 by 3. That's your option number B. And then we need to write equation of directrix. So equation of directrix. So equation of directrix is capital X equals minus A. So that is X plus 5 by 3 equals minus 2. So it will be 3x plus 5 equals minus 6 and it is 3x plus 11 equals 0, and that's your option number C.